was to solve square root and other radical equations. So find your spot in there. We did, let's see, the crater problem. That was the last one that we talked our way through. And I don't know, every once in a while they seem to put a word problem in here where it just seems like filler because it's not necessarily a great word problem for what we have. This was one of those where we're just basically putting numbers in and doing a little manipulation. So now, how can they get hard? I mean, we did square roots, we did cube roots. How can this get a little harder? Well, what if there's more than one radical in one problem? Huh? Ever think of that? More than one radical in one problem? Well, when we raise each side of an equation to a power, we know about this fancy word called extraneous, which means that we're going to get an answer. We'll have done all the math right, and we plug it in, and it doesn't work. What a bummer that is. So if none of our answers work and we've done all the math right, then what that means is it doesn't have any solutions. And that happens. It does. So we're going to find different ways to take a look at that today. We're going to continue checking algebraically, but we're also at some point I'm going to show you on the graphic calculator how we can check and see if these solutions work. So we do need to check our solutions whenever we're raising something to a power. I will tell you, it is very rare that raising something to an odd power gives you an extraneous solution. It's usually the even powers. And we all know, it comes from the fact that to undo squaring something, you use square root, which involves a plus or minus. So those are the things that make this happen. So problem 4 says, check for extraneous solutions. Well, we have to solve it first. What's the solution of the square root of x plus 7 minus 5 equals x? What would you do first? We should add the 5. You're exactly right. Because yesterday they said the most important thing is to isolate the radical. We isolated the radical. How do we undo square root? Squaring. Oh, this is different. Yesterday it was always just a number over there. Well, this will be the easy side, x plus 7. Over on the other side, we have to physically find out what that is. Now, if you want to do FOIL, you can write x plus 5 times x plus 5. But really, at this point, my hope is that you remember, wait a minute, perfect square trinomials came from these. And those weren't difficult because all you did was took the first term and squared it, took the last term and squared it, and then to get the middle term, you take a times b and double it. X times 5 is 5x, 5x doubled is 10x. Now, if you didn't understand a bit of what I just said, you can always FOIL. You can. I'm not going to force you to know the formula. It does make it go a little faster if you know the formula. Wow. That does not look like yesterday. That has an x squared. And it's going to have an x, and it's going to have a constant. How do we solve that stuff? We factor. She gave us factoring problems in the homework yesterday. Yeah, because we have to start getting our factoring skills back. So we're going to subtract an x from both sides, and we're going to subtract a 7 from both sides. And then we're going to see what we have to factor. So x squared plus 9x plus 18. Let's see. There's no greatest common factor. It's not a perfect square trinomial because 18 is not perfect square. But good old-fashioned factoring, I think, will help us in this. Give me the two numbers. 3 and 6. Which makes our solutions what? Now when you're solving quadratics, which is what we had an x squared, that's quadratic. Solving means find the zeros. So that's why it was so important that we had a 0 on one side. With quadratics, you want to do that. Then you want to see if you can factor. These two make me suspicious. Here's why. Our original problem had square root in it, and these are both negative. I think we might finally see an extraneous example here. So we better check these and see what's going on. So our first answer that we said we had was -3. So let's see if that works. Square root of -3 plus 7 minus 5 is supposed to come out to -3. Let's see. -3 plus 7 is 4. The square root of 4 is 2. Hey, that one works. -3 is good. -6, maybe not so much. Square root of -6 plus 7 minus 5 equals -6. -6 plus 7 is 1. Square root of 1 is 1. 1 minus 5 equals -6. No. Doesn't work. So finally, after yesterday going through all those problems and everything worked out hunky-dory, we see, yeah, not always. And I think, well, why did that happen? We squared both sides. Squaring, taking things to the 4th power, the 6th power, the 8th power, it's going to happen. Not all the time, but it's going to happen. So down here, we have another fabulous looking problem. Square root of 5x minus 1 plus 3 equals x. What's your first step, everybody? Subtract 3. Yeah, get that radical isolated. That you didn't see a new list of do this today. It was do the same stuff and see what happens. So what's next? Square both sides. Show of hands. How many of you are just going to keep foiling over there on the right-hand side? Like I said, as long as you do it right, it's perfectly fine. But it's a little shorter to say, I'm going to take this and square it. I'm going to take this and square it. And then to get my middle term, I'm going to do a times b and double it. X times -3 is -3x. You double that, you get -6x. We have an x squared. We have an x and we have a number, and we're not getting rid of any of them. So what would the next step be? So moving the 5x over, what else could you do while you're there? Add the 1. And if you do that in 2 steps, that's perfectly fine. I just don't have a whole lot of space here, and I write really big. You go through your list. Greatest common factor. Something I could pull out of all. Nope. Perfect square trinomial? 10's not a perfect square. Well, good old-fashioned factoring. Can we come up with 2 numbers that multiply to 10 and add to -11? -10 and -1. So our answers would be 10 and 1. Now, that bells and whistles don't go off saying, oh, these are probably going to be extraneous for this one. And that's because they both came out positive. Whenever I have a square root, immediately if I see negatives, I'm like, oh, they're probably not going to both work. So we do still have to check these because chances are it might not work. Never know. So we'll put a 10 in here, back up in the original. Square root of 5 times 10 minus 1 plus 3 equals 10. Well, 5 times 10 is 50. 50 minus 1 is 49. The square root of 49 is 7. The 10 is golden. It's working. Let's try the 1. Square root of 5 times 1 minus 1 plus 3 is supposed to equal 1. 5 times 1 is 5. 5 minus 1 is 4. Square root of 4 is 2. Uh-oh. That doesn't work. That's not equal. That one's out. So we get our answers. We had full knowledge that we had to square both sides to get this answer. And especially if you have to FOIL or square a binomial using the formula. You might have an extraneous. You just have to look. Have to. So now, this is some nice algebra we've been doing to check these answers. What we need to know is we got a nice $100 tool here that can also help us check it. And even if you don't have one on you today, you can just watch up there on the TV and you're going to see what I mean. Because if we go back to this problem up here. We have a way to solve this with the graphing calculator. And how we do that is we put one side in as y sub 1, and we put the other side in as y sub 2, and we find where they intersect. Because where they hit each other is where they're equal. So, give my graphing calculator a try and say, oh, graphing calculator, I need square root of x plus 7, parentheses, so it knows just the square root of that, minus 5. And on the other side, y sub 2, I just want to see x. And I want to know where they're hitting each other and how many times. So, zoom 6, there is our square root, there is our x, and they're only hitting in one spot. So I look at where they're hitting, and I realize, oh, for goodness sake, can't grab my yardstick. 1, 2, 3. That's my negative 3. That's the one that worked. My other solution, negative 6, 4, 5, 6. They're not hitting each other out here. It's a good thing we checked. It's not going to happen. Only one of those is going to work. So this is another way to figure it out. And you can always use Blinky, my pet cursor. Second trace, number 5, intersection. Bing, bang, boom. And Blinky will tell you. Oh, come on, Blinky. Don't let me down. Intersection, number 5. Bing, bang, boom. There we go. But they're intersecting at negative 3. So we have the right answer. There's Blinky, my pet cursor. So, what happened with this one? Well, I'll try this one too. I'll put this in as y sub 1. I already have the x in there as y sub 2. Let's see. So this one was the square root of 5x minus 1 plus 3. Graph. They're only supposed to hit each other at 10. Yeah, they don't hit each other at 1. It's not going to happen. And again, you could use second trace number 5 and let Blinky show you that they're intersecting at 10. So what this is saying down here with all its blah, blah, blah is what I just did with you, with my graphing calculator up there. If, for whatever reason, we're just brain dead after doing the test and we see it says check for solutions, we certainly could grab the graphing calculator, but if you do that, because the problem says check for solutions, you're at the very least going to have to write this down for me, GC for graphing calculator, so that I know you checked those solutions. Otherwise, you're going to miss a point for not checking. So one way or another, you have to be able to get it across to me that, hey, I used my graphing calculator to check this to make sure it works. So algebraic or graphing calculator, get it done. Make sure you check. If an equation contains not just one, but 2 radical expressions, or 2 terms with rational exponents, here's what we have to do. We're going to get the toughest one by itself first, and we're going to raise it to a power to get rid of it. The problem is, we're still going to have another radical. So then, we'll go after the second one. So we want to get rid of the toughest one first, and then work our way to get rid of the other one. So it says isolate one of the radicals, one of the terms, then eliminate it or its rational exponent. Isolate the more complicated radical expression first. Make your life a little easier by getting rid of the most difficult one first. Then, go after it again. You still have a root in it, just keep going and see what you can get. Oh my. That is a monster. In fact, it's growling at us. It's growling back. I'll never back to you. We want the radical that's the toughest radical here all by itself. Of these 2, which would you say has the bigger muscles and is tougher? The 2x plus 1. Yep. You're staying put. You are going to the other side. Like so. Our focus is still on that more difficult one, square root of 2x plus 1. I want to get rid of that radical. What should I do? Square both sides, which is such a great idea over here because when you square this, you get 2x plus 1. Woohoo! But there. Square root of x plus 1. You could write it out twice, and you could FOIL it. Or, remember what we do. We square this one, that'll give us an x. We square this one, that'll give us a 1. And to get the middle term, we multiply them together and double it. Square root of x times 1 is 1 square root of x. Doubled, 2 square roots of x. That's a big deal, by the way. Now we're down to 1 radical. We already know how to do this. So if we have 1 radical, we're going to get the x and the 1 over to the other side, and then we'll take care of business again. So we'll subtract an x and subtract a 1 from both sides. 2x minus x is 1x. 1 minus 1, 0. Looks like so. Now, if you don't mind working with fractions, you could certainly divide by the 2 right now before you square this. But usually what that does is it overcomplicates the situation. So most of the time we recommend that right here you square both sides. But then you have to be careful because we're not just squaring the square root over there, we're also squaring the 2. So 2 squared would be 4. The square root of x squared is x. Is this a quadratic? Yeah, it has an x squared. We're always supposed to solve those by factoring, so we're always supposed to have a 0. So I guess I better move this 4x over. How do you factor something looks like that? Take out that greatest common factor. We're going to factor out an x. Well, what does this give you for a solution? Exactly, 0, because 0 times anything would be 0. So 0 is one of our answers. What's our other one? 4. Maybe they both work. Maybe just one works. Maybe neither one works. What would you put down if neither one of them works? Yeah, no solutions. But let's check and see. All right, back up to the top. If we put a 0 in here, 2 times 0 will be 0. 0 plus 1, the square root of that, minus the square root of 0 equals 1. Well, 0 plus 1 is 1. Square root of 1 is 1, and 1 minus 0 is 1. Cool. At least one of our answers works. Let's try 4. Square root of, 2 times 4 is 8. 8 plus 1 is 9, minus the square root of 4. Does that really equal 1? This is going to be 3 minus 2. Hey, they both work. So, sometimes neither of them work. One of them works. Both of them work. It's got 2 radicals. All right. Lead me through it. What you thinking? Since you're already doing it, all you would really have to do is like talk about what you're doing. What are you doing? Add that square root of x. Oops. Okay, we isolated the nastiest radical. Now what? Square them. Where'd your squaring go? Get it? Square root of x squared is x. 4 squared is 16. Multiply the square root of x times 4 and double it. What's up next? X in a 16, okay? You want to move the 8 over and get fractions, or are we going to square it right now? is where people usually make the mistake, right there. If anybody's going to make a mistake on this problem, it's coming from that. Remembering that 8 also has to be squared. Ooh, yuck. Ew. Not looking too fun to factor, but we're not done yet, right? All right, what's up? What's next? Subtract the 64x. Okay, well, let's see what happens. Negative 96 minus 64. I don't know about you, but I sure hope there's the greatest common factor we can pull out of all of this. In fact, which one would we love to pull out of this? 16. 16 going to 144? Oh, yeah. It does. This just became a much easier problem. 16 times x squared minus 10x plus 9 equals 0. Do we care about that 16 outside the parentheses? There's no answer out there. There's no x there. So it's nice that it came along for the ride, but it's not part of our answer. So we're going to put the 16 out here just knowing, hey, we should make this look right. But our answers are going to come from here. Now, at first glance, you might say, hey, Cedar Homie skipped a step because that might be a perfect square trinomial. I did it in my head, and I have to stop doing that. 3 times x doubled. Does it give you 10? So, no, not going to happen. Doesn't mean it's not factorable, it's just not a perfect square trinomial. You have 2 numbers for me that'll make this work? Maybe they both work. Maybe they don't. I'm going to check this one with my graphing calculator. So let's see. If we put the left side in as y sub 1 and the right side in as y sub 2, well, let's see if they hit twice. Square root of 5x plus 4, parentheses, minus second square root of x, parentheses, and we want to know when that hits 4. Oh. It's only hitting once. Whereabouts do you suppose it's hitting? Yeah, and then we could get Blinky, my pet cursor, out. Blinky says 9 is it. X is 9. Big GC. Graphic calculator. Those were the tough ones. There's some good algebra in those problems there. 42210 me. Solving our stuff with the double radicals. I want to know how you're feeling about the double radicals. Okay, not too bad a number. Some feel a little less confident than others. But with practice, I'm sure you're going to do just fine. And you know what? There isn't really a lot of good practice. I think maybe you get 2 of these in today's homework that are double radicals. But that's okay. That's okay. Because they take a while. You know, when you get done here, check in and make sure that your answers are right.